Thank you everyone. Today I discuss about conductivity. First of all, what do you mean by conductivity? Conductivity tells us how easy the current flow through the conductor, and it is the reciprocal of resistivity. Now the question is, what do you mean by resistivity? Resistivity tells us how much opposition is offered by the conductor at the time of current flow. That means conductivity means how easy the current flow. Resistivity means how much opposition, how much amount of opposition offered by the conductor. That means resistivity and conductivity both are the just opposite to each other. Here the conductivity it is equal to 1 by resistivity. It is conductivity equal to 1 by resistivity. Conductivity it is denoted by sigma is equal to 1 by resistivity, it is rho. So sigma is equal to 1 by rho. This is the relation between the conductivity and resistivity. That means both are reciprocal to each other. Now we know that the resistivity, the formula for resistivity, it is R A by L. That means resistivity rho is equal to R A by L. What is R? R is resistance of the conductor. What is a cross section of the conductor? And L is the length of the conductor. If rho equal to RA by L, then sigma equal to 1 by rho. That means 1 by RA by L. That means L by RA. This is the formula for sigma. Another question is, to measure the sigma, we use this formula or you use this formula. Now we need a unit for sigma. What will be the unit of sigma in SI system? Here we know that the SI unit of resistivity, here the SI unit of resistivity, what it is, the ohm meter. This is the unit of resistivity in SI system. Now what will be the conductivity? what is the SI unit of conductivity? As the conductivity is the reciprocal of resistivity, then also the unit will be just inverse. It will be ohm minus to the power minus 1 m to the power minus 1. This is the unit of conductivity. Ohm to the power minus 1, it can be write down like that, OHM MHO, just in reverse order. Ohm to the power minus 1, meter to the power minus 1 means per meter, that is mho per meter. It is the unit of conductivity. Now this resistivity and conductivity, both these two does not depend on the length of the conductor and the cross section of the conductor. That means they do not depend on number 1, length of the conductor and the cross section of the conductor. On these two factors, the resistivity and conductivity does not depend on. That is why conductivity and resistivity both are the characteristics property of the material of the conductor. Now the question is, this conductivity and resistivity depends on which factor? Does not depends on length and cross section, but question is on which factor they depend on. Conductivity and resistivity depend on first one, temperature. Number 2, material. Of the conductor. On these two factors, the conductivity and resistivity both depends on. Now the question is how the conductivity and the resistivity depends on temperature. For first, resistivity. Say it is the temperature, then resistivity, and then current. Temperature when increases, then resistivity of the metallic conductor, here the metallic conductor increases. If the resistivity increases, current decreases. Temperature increases, resistivity then increases, then the current flow through the conductor decreases. If temperature decreases, then resistivity also decreases. If the resistivity decreases, then current increases. That is the way how the resistivity depends on temperature. But here the temperature is not directly proportional to the resistivity. Does not depends on resistivity. Now temperature when increases, resistivity temperature increases, resistivity increases. Temperature decreases, resistivity decreases. But resistivity is not directly proportional to temperature. If the temperature decreases, resistivity decreases. But at absolute zero temperature, resistivity does not becomes zero. That means this resistivity does not becomes zero at 0 degree Kelvin. 0 Kelvin. At 0 Kelvin it does not becomes 0. Now what is the relation between temperature and conductivity? Just it will be just opposite to the resistivity. Temperature and conductivity. Temperature increases. What will be the conductivity? Conductivity decreases. That means if the conductivity decreases, then the current decreases. If temperature decreases, then conductivity increases. If the conductivity increases, then the current also increases. That means at the lower temperature, the conductivity is more. As the conductivity is more, the current is also more through the conductor. But at the absolute zero temperature, the conductivity does not infinite, does not becomes infinite. But at absolute zero temperature, conductivity is very, very high. That means very more amount of current flows through the conductor, but it does not infinite. All these are applicable on the metallic conductor. Now, for the alloys. For alloys like constant, nichrome, then if the temperature increases, then their resistivity and conductivity generally remains unchanged, or if changes, it changes very slightly. For the semiconductor and the electrolyte, if the temperature increases, resistivity decreases. That means conductivity increases. For the alloy, for the electrolyte and the semiconductors. Now, some metallic conductors are there. When temperature decreases, after certain temperature, the resistance of that metallic conductor abruptly decreases. As the resistivity abruptly decreases, the conductivity generally increases, and below a certain temperature, their resistivity becomes very, very low, and at that temperature they behaves as a superconductor. For mercury, Hg, nearly at 4.2 Kelvin temperature, its resistance becomes very, very low and used as a superconductor. What is the advantage of superconductor? If the one time the current flows to the superconductors, then if we remove the source of the electricity, then also the current remains for a weeks. This is the superconductor. So this is the factors on which the conductance and the conductivity and the resistivity depends on. What is their relations? The metallic conductors, silver, copper, silver, copper, aluminium, they have very less resistivity. That means they have low resistivity at normal temperature. As its low resistivity, so they have high conductivity. They have high conductivity. As they have high conductivity, that means they are low resistivity at the normal temperature. That is why these metals are used for making current carrying conductors. But copper and aluminium, these two, are used widely for making the current carrying conductor. Why? Simple, because they are the good conductor of electricity. That means their resistivity and conductivity, both conductivity is high, resistivity is low, and also they are comparatively cheaper than silver. That is why these two are used widely for making the current carrying conductor in our practical life. Thanks. In next video, I discuss about what is the difference between the conductor, resistor, and the insulator. Thank you.